Reviving the Heart of Africa. How to replenish Mega Lake Chad. To be able to grow a lot more crops in large parts of the Sahel and the Sahara. A bonus or the main reason to go ahead with the Sea at Level project to reduce global sea level rise. Adaptation. Due to a slow increase in the global temperatures, more ice is melting. Lakes and swamps are drying up and there is more desertification. This water does not disappear but ends up in the air and eventually in the oceans. Directly linked to the rising sea level is the decrease of the freshwater buffers that provide so many people with water. The water from these glaciers, lakes and rivers also makes it possible to grow crops and keep animals. We have to find ways to store more fresh water on land. The best option is to find a lake that was once a lot bigger and fill her up again. It would be great to find one in an area where there already is a water and food crisis. And to try and solve that too. It could even be argued that securing adequate water is key to preventing poverty-driven terrorism and wars. It increases employment, business opportunities and improves overall living conditions. But during the transition period, when the basin is being replenished, and expands rapidly, the replacement of people might give rise to tensions. So there must be very generous compensations, and a dedicated independent organization to provide all kinds of assistance in this process of resettling at a new location. Basin. Some people refer to Chad as the dead heart of Africa, because it is so hot and dry. But the Enedi Plateau in the northeast, a UNESCO World Heritage Site, is known for its large collection of prehistoric rock art depicting cattle and even giraffes, which is also true for neighboring Niger. The Sahara, the Arabic for Great Emptiness, once looked a lot different. A former lake means a depression in the landscape. The ASTA satellite data provides the digital elevation map used here. It is clear there are two main depressions that interconnect once we virtually raise the water level to 285 meters above sea level. Currently only the southern Lake Chad still contains some water. South of Lake Chad, a remarkable feature can be seen, which is the runoff of a huge lake. It is now called Mayo Kaby. This overflow fixed the level of the lake for a long time, leaving a shoreline that is still visible at 321 meters above sea level. To the northwest of this outlet, there may have been another one at 367 meters. It cuts through a crest currently at 415 to 428 meters. Is this eroded crest an indication for the maximum water level? Or was it caused by waves, and is 380 to 400 meters a more realistic maximum? That would mean the mountains near Mayo Kaby have eroded far more. Perhaps because it was exposed to the prevailing winds from the northeast. Whatever the reason, what if we put a dam in the Mayo Kaby and a smaller one in the other? It creates a basin for a possible lake with an area of over 800,000 square kilometer at 380 meters. Crops and carbon in the Tenere Desert. To the northwest, the mega Lake Chad borders Niger's Tenere Desert. This desert is remarkably flat over a vast area. It may once have been a swamp. But let's assume that the lake is at 380 meters and the same for the water table in the Tenere. A water table is not a sharp separation between wet sand and the dry sand above. Many meters above this level the sand will be humid. The area of 0 to plus 50 meters above the water table, which is 170,000 square kilometer, will be suitable to grow plants varying from rice to deep-rooted trees. Year after year, a network of channels could be expanded to improve irrigation and expand the agricultural area. Trees will provide building materials and are an excellent way to capture carbon. All this water and extra green will improve the climate in the Lake Chad Basin and reduce the impact of CO2 on the global greenhouse effect. In addition, there is also a vast area from 0 to plus 50 meters along the rest of the lake's shoreline. The total shoreline, including near the Tenere, is 4,300 kilometers, which is more than double the length along the Nile in Egypt. Much of the wide area along this shore can also be used to grow crops. However, if we stop filling the lake at a maximum of 350 meters, there will probably be more suitable area on the shore of the lake. A smaller lake will also have a positive effect on the local climate, and could give enough rain for grass and shrubs in parts of the Tenere. But further away from the lake it will remain a desert. Water. There is not enough rain. So what if we increase the catchment area? In the Central African Republic, Congo-Kinshasa and Congo-Brazzaville, rain regularly causes flash floods. Several months a year there is too much rain. Can we dump it in Lake Chad? What if we built a dam directly north of Bambari? The area upstream of the dam will fill up, and at some point the water level will reach the lowest part of the surrounding mountains. That's in the north. The water will spill over into the Chari River, which flows all the way to Lake Chad. It will also be a reservoir for irrigation, and a hydroelectric power plant that provides electricity. Improving living conditions is crucial in order to get nationwide support. By constructing a new dam every few years, the catchment area gradually expands further by diverting water. When certain water levels are exceeded, this increases safety downstream. Fewer crops and property will be lost. The excess water is all diverted to Lake Chad. Ultimately, this proposed additional catchment area will be 392,500 square kilometer, with an average annual rainfall of 1,500 millimeters. The total amount of rain is about 590 cubic kilometer. But not everything ends up in the rivers. After subtracting 15% for evaporation and other losses, diverting just over half of the total volume could result in a 321 meters lake in 50 years' time. 350 meters in 50 plus more years, and at 380 meters after 80 plus more years. But taking away more than half of the volume of the Ubangi River will probably be too much to get the go-ahead from Congo-Brazzaville and Congo-Kinshasa. Therefore, part of the plan has to be the construction of a dam in the Labaye River, or elsewhere in Congo-Brazzaville or Congo-Kinshasa to store water in the rainy season, so the level of the Ubangi coming from the Central African Republic and the Congo River can be increased when needed. Sea at level. When the surface of the lake is at 380 meters, it contains more than 47,235 cubic kilometer of water, divided by the surface area of the world's oceans. This alone could compensate for a rise of over 13 centimeters in sea level. In reality, significantly more, because the sand and the sandstone below 380 meters elsewhere in the Lake Chad Basin aquifer, which includes the Tenere, will also absorb water, and along the shores there will be a vast area with irrigation and plants. Allowing the lake to reach 380 meters creates another opportunity. Somewhere around the 380 meters level, the lake touches the edge of the Nubian sandstone aquifer system. It is the largest in the world with an area of 2,162,500 square kilometers in northeastern Chad, Libya, Egypt and Sudan. The dry Qattara Depression in northwestern Egypt cuts through its sandstone layers. This depression is 133 meters below sea level at its deepest. Studying the digital elevation map and proposing a dam at the western edge will create a basin for a lake that can safely be filled to over 60 meters above sea level. This allows us to make a rough estimate of how much extra water the aquifer can contain. 133 plus 60 meter times 2,162,500 square kilometers times 7.55%. Dry space within the sandstone equals 31,500 cubic kilometer. The Qattara Lake itself will contain 3,250 cubic kilometer. To the east it is close to Alexandria. It could provide the city with water, fish and electricity. And in the west the same for Libya. The water also makes it possible to grow crops and keep animals around the lake. Perhaps there are subsurface cracks in the rocks at the location where Mega Lake Chad and the aquifer touch. It would explain how Qattara Lake once could have existed. The answer could lie in the salt composition in both lake beds, or in the oxygen and hydrogen isotopes of the local groundwater. If not, or to increase the flow towards Qattara, it is possible to dig a short channel from the mega lake in north-northeast direction, and then drill several holes to reach the sandstone layers of the aquifer. It will take some time for the water to reach the depression, but the beauty is that there is no need to dig a channel all the way to the north of Egypt to fill Lake Qattara. In the 1980s, Libya drilled wells to reach the Nubian sandstone aquifer, and constructed giant pipes to transport the water pumped from the aquifer for irrigation. It's called the Great Man-Made River Project. In the West they did the same with the Northwest Sahara Aquifer System, which is over 1 million square kilometer in size and extends to Algeria and Tunisia. When there is a need to store even more water, this aquifer can be reached with the same kind of piping system, starting from the main irrigation channel in the Tenere. The former mega lake Fezzan is on top of this aquifer, but because of its elevation only in the lower regions some water can seep in from the aquifer. Constructing a giant pipeline like that from the Tenere towards the Qattara Depression would create the possibility of having several power plants along the way to the depression. Libya could remain an exporter of energy when it switches from oil to hydroelectric power. By filling the depression, the water will also seep into the Nubian sandstone aquifer, so the effect for Egypt remains the same. The final power plant will be in Egypt, near Shiva oases, so working together will have clear benefits. The third aquifer that could be utilized is the Erheza-Illumidan Basin, which lies just to the other side of a low mountain range in Niger, and extends over 500,000 square kilometers. There is a need for more data, but overall the reduction in the global sea level rise will probably be substantially more than this first estimate of about 25 centimeters. All this water and plants will release extra water vapor into the atmosphere, causing more rainfall in other areas. Those areas and the aquifers underneath will now also absorb and store more water. The need for speed. When the plan expands into Egypt, or to speed things up, the catchment area can be expanded even further. Scanning the eastern edge of the Congo Basin, the first major river is in the south, the Lukuga coming from Lake Tanganyika. However, it is more than 1,000 kilometers from the Uele River. But crucially, there are too many canyons and ridges to cross to connect it to the Uele. But it may still be relevant to the project. Instead of an additional reservoir in or near the Central African Republic, to compensate for the reduced amount of water in the Ubangi River, the Lukuga could also be used for this because its water will also flow into the Congo River. This will increase safety along a much longer stretch of the river. Studying the digital elevation map shows that it makes much more sense to use the Semliki River to enlarge the catchment area. This river is coming from Lake Edward and flows into Lake Albert where the White Nile begins. It is at an elevation sufficient enough to connect it to the Uele River. There is only one modest mountain ridge to cut through, and there are no major obstacles to reach the Uele River. To minimize the impact on wildlife and agriculture, giant underground pipes like those in Libya could be used. The advantage of using pipes instead of an open channel is that no continuous descent is required. This makes it a lot easier and cheaper to traverse uneven terrain. A hydroelectric power plant could provide the nearby city of Butembo with electricity. If part of the river's volume is siphoned off, this will most likely result in protests from both Sudans, even if it is only in the rainy season. But on the other hand, the flood risks would reduce, especially for South Sudan. On a budget. In all, it's an expensive idea but much cheaper than dealing with the effects of a global sea level rise. Should the cost of the project be paid for by countries with an ocean coast? But this accelerated sea level rise is the result of the use of fossil fuels. It is strange there is one fuel that is not taxed. Article 24 of the 1944 Chicago Convention on Civil Aviation states, fuel, on board of an aircraft, on arrival in the territory of another contracting state, and retained on board on leaving the territory of that state shall be exempt from customs duty. That is no obstacle to tax the fuel that is burned in that territory. If the tax is the same everywhere, and it all goes to one project, it doesn't even matter which country collects the tax. Simplified. Put a tax on sales. According to the IATA Fuel Facts sheet, The global airline industry spent $188 billion on aviation fuel in 2019. With a 10% tax and a rough estimate of the effect of the coronavirus, and an increase in fuel costs, the total fuel costs could drop 20%. Then the tax is still about $15 billion a year, which is more than the GDP of the Central African Republic and Chad combined. The global average tax on fossil fuels is much higher, so it makes sense to increase this tax by 1% every year, until it is roughly the same as for the other fuels. Concluding remarks. The extra arable land is bigger than that in Egypt. There will no longer be a shortage of food, but plenty to export. By creating the largest lake in the world, it is possible to develop a huge fishing industry. In many new locations, hydroelectric power plants will provide cheap electricity, because construction costs are already covered. Where these power plants do not have a reservoir, additional solar panels with salt water batteries can provide a constant power capacity for day and night. But, especially the people of Chad would lose a huge part of their country, including the capital N'Djamena. In Nigeria, the major city of Maiduguri has to be relocated more than 80 kilometers to the southwest. This plan can therefore only be realized if there is sufficient budget to generously compensate for the loss of property and the move to a new location. The realization of the plan will lead to a reduction of the sea level rise, and the capture of more greenhouse gases. The bill has to go to those who burn fossil fuels, and not to the countries that provide part of the solution. Many thanks to the developers of QGIS and the plugins. OpenStreetMap. Global Digital Elevation Map. Version 3. Copyright Astra G-Dem by METI, Japan Space Systems and NASA. White's Engineering Solutions.